Hello, this is Satbir. The topic of our discussion in this video tutorial is inverse function. The inverse of the function f of x is typically denoted by f inverse x. This is not f to the power negative xx. Actually, this is read as f inverse of x. So it is just a notation for a different letter of x. And it is defined that if a function has a value, output value b on the input a, then to reverse that process, we define the another function who takes the output value of the function and produce the input value. So let me give you an example. For example, if a function at 2 gives a value 10, or like a real world problem, if you want to think. So if you produce two quantity, it cost, this is a quantity and this is a cost. It cost $10 to produce two object, and we sometime may be interested that how many quantity I can produce in $10, and that will be two, because it's the same sort of setup machine, but it give us the inverse information of the machine we have. Because if I'm producing two quantities, going to take me $10, at some point maybe I will be interested that how in $10 how many quantities I can produce in the same machine. So the answer will be two. More example, if f is a function which produce, if the value of the function f at 2 is a 30, then we can only compute what is f inverse of 30, and that will be 2. So basically it's a reversing the process of the function f. So since we reverse the process of the function f, then the domain of the function f actually become the range of the function f inverse. And this happen for the range also. They switch actually to range and domain. So the range of the function f become the domain of the function f inverse. So in order to switch their range and domain, the function must have to be 1, 1. So what does it mean by 1, 1? That a function cannot produce same output at two different values. For example, if a function producing at 2 the output 6, and also at 3 the output 6, this is a definition according to the definition of function. It is a function, but this function is not 1, 1, not 1, 1, because it produces the same output. So the reason is that if this produce the same output at a two different value, we won't be able to compute the inverse of 6, because we won't be sure whether it will be a 2 or 3. So a function cannot have two output, therefore f will not be a function. So you can only define a inverse if there is a one-to-one correspondence, means each different input must have a different output. Now here one more exercise. Here we have given the table, and in that table we can clearly see that if I look at x is equal to 10, the value of the function is a 15. Now how to calculate f inverse of 10? So usually we look at what will be the value, because this is how it is defined. So what will be the value at what input the function will produce 10 as an output, because here the output goes here. So this is what we are asking ourselves. What input of the function have produced the 10 output? So as you can see, here is a 6. If I plug 6 here, negative 6 here, it produce 10 as an output. So I will place here negative 6. So from this information, that it means if I have to reverse that process, that will be a -6. So this is the end of this problem. Here I have one quiz problem for you to practice. Please pause the video for 1 and 2 minutes and work on this problem. Next, if we have the algebraic equation for a function, how to calculate it is inverse. So here the function is given f of x is equal to 3x plus 2, but I'm going to write in this notation. Instead of writing f of x, I can write y. That is okay. So we're going to replace this. So this is our function, and we want to compute the inverse of this function. This is a two-step process. In step number 1, what we're going to do is we're going to replace x to y. So we're going to switch wherever you see x, we're going to switch that to y, and wherever you see y, you're going to switch that to x. So our new equation will be x is equal to 3y plus 2. That will be our new equation. And in this step number 2, we will solve for y. Now we need to solve this algebraic equation, and we need to solve this for y. That is our second step. So in order to solve, first I need to subtract 2 from both sides. I will get x minus 2, 3y, because I just subtract 2 from both sides. And then I will divide by 3 on both sides. So divided by 3 here, divided by 3 here. So if I divide by 3, I will get a function which is a y is equal to x minus 2 divided by 3. So this is our inverse function. This implies f inverse. I'm going to switch now y to the notation form of the function. So f inverse of x is x minus 2 divided by 3. So this is our inverse. Next, I have one more quiz problem for you to practice. Please pause the video for 1 and 2 minutes and work on this problem. Next, briefly, we're going to talk about the graph of the function and its inverse. Is there any relation between them? So my first example of the graph is so what if I have a graph of the function y is equal to x squared? So this is going to y is equal to x squared. We know that if I calculate the inverse of that function, f of inverse is going to be square root of x. That is going to be the inverse of this function. And the inverse of this function is this. Therefore, the graph of that function is going to be something like that. And then you might be notice there is a relation between these two graphs. And these two graphs has been a reflection of each other along the y is equal to x line. So this is the y is equal to x line, which is a 45-degree angle to the x-axis. And these two functions are a reflection. If this is a f of x function, y function, then this is a f inverse of x. So to plot the graph of the inverse function, all you have to do is you have to reflect the function along the y-axis. Let me take one more problem. So this time I'm going to take this graph. So this is the graph of the function is goes through 1 and this goes through like this. So how to basically reflect, because we say last time it is the reflection along the y-axis, so this is the y-axis. Sometimes it's a bit more difficult to reflect certain graph over this. So reflection along y-axis means if you take this distance, perpendicular distance to the y-axis, you have to take same perpendicular distance and mark a point. Like for example, this perpendicular distance, you have to take same distance and mark. So this is lines are getting bigger, so line should get bigger on this side too. So this one will go here. Same like this is a 0, and then it should be here. This is a here, that should be here. You know, so like how much you are away. This point is away perpendicularly from the y-axis. It should be same amount. So as you can see that once you draw few points, you should be able to plot the graph, because all you need to do is you have to connect these points. So this is the graph of f inverse of x, and this is the graph of the function. So in order to reflect the graph, so each point on the graph must be reflected individually over the x-axis. Or in other words, the perpendicular distance from the y-axis of this point should be on the other side and the same perpendicular distance. Okay, this is the end of this video. Thank you very much for watching. I will see you in the next video. Bye for now.